Welcome, Unity developer, to this next tutorial. We're going to actually continue on with our C# series, and in this one we're going to take a look closely at the switch statement. Let's dive right in. So first of all, let's cover off just exactly what a switch statement is at a high level. Let's say you have a variable and you want to compare that variable against a list of constants. Then the switch statement is definitely for you. You can think of the switch statement as sort of a streamlined conditional statement. Where we looked at if statements, you had the if statement and then the condition and then what to do when that condition was met. And then if there's any other conditions, you then add on the else. And if there's anything else after that, it'll be else if, else if, else if, else if, else if. And that gets messy really quickly. And a way to tidy that up is to use the switch statement. So how is this switch statement put together? Let's take a look. So the first thing we're going to do is actually create a variable that we can compare. So we're going to get rid of the start and update methods for the time being. And we're going to create a serialized field because we want to be able to adjust this in the inspector, but it needs to be private because it's only going to be accessed by this class. And we're going to create a data type of int, and it's going to be called player experience. We'll go ahead and leave the initialization at the moment. We'll just go ahead and put a semicolon at the end. Then in our start method, so we did need the start method after all. We're going to go ahead and call another method straight away called compare player experience. I haven't created this method yet, so we're going to get a red squiggly line. I'm going to go ahead and press Control and full stop and hit enter to generate the method. So in here, this is where we're going to actually write our switch statement. So the basic syntax of the switch statement is going to be the keyword of switch, and then open your parentheses and enter the condition, and then close it off, and then you will need a pair of curly braces, and then inside the switch statement you're going to need a case statement for each possible path ending with a colon, and then after the case you're going to have your individual lines of code followed by the break keyword and semicolon. So let's look at a practical example for this. Let's go ahead and we'll write our keyword of switch. And what do we want to switch? What do we want to compare? We want to compare our player experience. Our player experience is of data type int. So we're going to say case 0. So if our player experience is 0, then it's going to do everything after the colon. We're going to write debug.log player experience is 0. Finish that off with a semicolon, and then we could go ahead, drop down to a new line and write break and finish off with a semicolon. So when we define our case statement, anything between its colon and the break keyword acts like a code block in an if-else statement. The break keyword just tells the program to exit the switch statement entirely after the selected case. So it'd get to this particular case. If it was 0, it'd do this line of code, and then it's going to exit out of the break and continue with your program. Let's go ahead and put another case in. Let's say the case is 5. This could literally be anything, and we can say debug.log getting better, and then break. So what do we do if none of these cases matched our player experience? Well, we can use the default keyword. Instead of case, we'd write default, and then you put in your colon. For the sake of our tutorial, we're just going to write debug.log no reference. That's not very exciting, is it? Cannot judge experience. Finish that off with a colon, and then again we put in our break keyword. So on start, we're going to go straight into our compare player experience method, which is just here, and then that's immediately going to fire off our switch, and it's going to compare our player experience, and it's going to try and match this against one of these cases, and this is called pattern matching. So in switch statements, pattern matching refers to how a match expression is validated against multiple case statements. All case statement values need to match the type of the match expression. So if we're trying to match an int, which our player experience is, it's of data type int, then each case must be of an int. So we're trying to match against these, and if it doesn't match, then it's going to jump to our default and print off cannot judge experience in our console. I'm going to go ahead and save with Control S. Let's jump back into Unity and give this a whirl. So here we are. I've got my game object from our previous tutorial. Let's click on that one a minute and get rid of control flow script. And we're going to head and add in our switch statement. And as you see, our player experience is 0. And in our script, if our player experience is 0, we're going to switch it to say debug.log player experience is 0. So that's what we should see in our console. Let's go ahead and try that out. Go ahead and hit play. And here you can see player experience is 0. Let's set that to 5 and we should get the other case that we set up just below. And then you can see we have getting better. And then when none of those match, see it goes to our default case, which is cannot judge experience. And the last thing I want to show you with the switch statement is something called fall through cases. So switch statements have the ability to carry out the same action for multiple cases. So let me show you an example of it. Say we wanted getting better to not only show if our integer value is 5, but also if it was something like 3. Just above the case that we want to use, we could put case 3 here and then simply put the colon. If a case is left empty, like we're going to do here with case 3, what's going to happen is it's going to jump down and go straight to case 5 and then debug the getting better message. Let's have a quick look at that in action. We'll go ahead and put 3 in the box and then clear our console and then run. And you see here getting better. So our code has fallen through case 3, and with no code there, it's automatically going to drop down to the next case below and show getting better. Now, don't get me wrong, switch statements are great when used in the right place and for the right use cases. A lot of developers don't like using them because it can be hard to extend your code if you've got switch statements in different places and then having to follow where they're going. Quite often there's other ways of doing exactly the same thing, which makes your code easier to update later on, such as using abstract classes and inheritance. But for small cases like something like this, it'd be absolutely perfect. And it's not like you shouldn't use them or don't use them, as long as, I think, if you start realizing that your program or application is hinging on quite a lot of them, then there's probably something wrong there and you may want to have a look at doing it in a different way. But really, switch statements are extremely powerful and can make even the most complex logic, once broken down into a switch, can become a lot more readable. So for now, that concludes our lessons on conditional logic. I think next week we'll probably start having a look at arrays and then following on from that, lists. But if you found this video useful and you're finding this whole tutorial series useful on C#, then please leave a like on the video, it really helped me out. Thank you very much, I'll see you in the next one.